So hi everyone, this is our first lab tour. We're going to interview people from the Smart Systems group, and we are here in Tirankato 8, which is one of our University of Turku buildings, so we can maybe go there and start talking. Hi. Hello. So, hey everyone, this is our first lab tour in the Smart Systems group. So, my name is Henrique, and I'm going to be interviewing this for researchers here. And yeah, that's pretty cool. So let's start. So what is your name?
Hi, I'm Lukas.
Cool.
Hi, my name is Kimmo.
Amos.
Hi, I'm Carlos.
Tell me a bit like how did you start Smart Systems? How did you find about the opportunity of doing research? If you started doing your masters or if you came just for PhD?
Yes, so I'm currently a PhD researcher here at Smart Systems. I started in Turku as a master student, so I did my master the past 2 years here, and then I continued as a doctoral student.
Cool.
I studied in the Turku University of Applied Sciences, and then I applied for the master's program here at UTU, and now I have studied for 1.5 years now, and I'm doing my master thesis now.
Very, very interesting. What about you?
Yeah, I studied my master's out of Finland and I decided to pursue my PhD and I got this opportunity. So I came to do my doctoral studies under mechanical engineering.
Very interesting. And where did you find out about the university? Like how was it? Did you search it like online? Did you see some LinkedIn posts? How was it?
Yeah, so after my master's, I subscribed to this Robotics Worldwide emailing list. So a bunch of PhD opportunities were coming through and I was applying and I happened to apply as well to University of Turku, Smart Systems, and that's how I got it. Yeah.
Very interesting. What about you?
Well, for me, I did my master's here. So basically, since 2022, I did that. Saw some positions related to a program pilot here, related to the research that I'm currently doing. And well, decided to apply and basically continue with a PhD. Yeah.
Wow, very, very exciting. So can you describe maybe like because we want to understand like what is the group researching, what is the group doing, what are the different projects? Maybe we can start from Lukas again.
Yes, so overall this lab here is researching for mainly robotics and automation project in mechanical engineering. My specific project is actually a flagship called Smart Systems Digital Waters. And basically the objective is to analyze the water in Finland, for which I am trying to build drone systems that can analyze water bodies such as lakes and rivers in a new way. So that's basically what I'm working on.
Well, that sounds very complex and very exciting at the same time.
I don't have any specific research except my master thesis, but I'm working as a lab engineer, so my role is to support all our group's researchers.
Yeah, which is also like a very important side of the research because you also need like people who are going to help with the equipment, who actually knows how to set up things so everything goes smoothly. That's also a very interesting side. And what about you, Amos?
With my background in mechanical engineering and image processing, so I'm doing research on drone fleet for environment perception. Coordinating a swarm of drones to be able to perceive and collect data in the wild. Yeah.
Cool. And you?
Well, basically, on my case, I did a master's thesis on 3D mapping. And this program pilot actually it's related to intelligent work machines. So it's basically applying 3D mapping with heavy duty machines. And in summary, it's basically merging 3D mapping with 3D scene graphs to increase situational awareness of heavy-duty machinery, basically.
So about the group itself, like how is the work structured? Like how do you work, let's say, more independently? Do you collaborate? What stage of research are you in? Like how is it? Maybe we can start.
Okay, yeah, because I started my PhD in August 2024, so far 7 months, and we've done mostly the preliminary work. Right now, I'm starting to develop the idea and So the nature of the group is like we always have bi-weekly meetings where we meet up with the supervisor and present our progress, and we get feedback and direction on what to do next. So yeah, we're still building up on what is coming up. Yeah.
Cool.
Well, in my case, it's actually quite funny because most of the time I either read a paper or take notes of a paper. There's a lot of collaboration, definitely, in the program pilot that I'm in. There are some colleagues in the University of Oulu and the University of Tampere. They are actually working on similar stuff. Currently working on a couple of papers with some colleagues in Spain from the University of Zaragoza. So yeah, lots of collaboration, lots of reading, lots of taking notes, lots of coding too. So yeah.
So what about you, Lukas?
Yes, so for my case in digital waters, most of my colleagues from this flagship are scientists specialized for water analysis, which is not really what I'm doing because I'm more working for the drones area. So I am not that actively part of the discussions because I'm not a specialist in water analysis myself. So I'm more taking part in these bi-weekly meetings here, listening to what the other people here are doing, because that's where I can improve more than throughout my flagship.
Yeah, of course. So you're creating, let's say, the data collection platform that then the other researchers are going to actually use to collect data, and then they analyze and do the other studies. That's very interesting. What about you? How is it for you to be a lab engineer?
I would say that this lab environment is very nice, and office spaces are nice. People can collaborate.
Yeah. Yeah, absolutely, because this facility here is actually shared between two research groups. More or less of a last question here before we get to other things. So what do you think of Turku as a place to study and to do research? Maybe we can start from Kimmo.
This is my hometown.
Yeah.
Yeah. I say that Turku is just the right size. There's not too much people, so there is no terrible traffics or anything like that. And here is everything you need, all the services, just the right size city.
Yeah, I agree. I really like this. Most or 80% of the city within like 15 minutes.
I think I totally agree with you guys. Also, if you're more someone who's interested in nature and outdoors and outdoor sports, this place is really perfect. And having also lived in much bigger cities than Turku, I think that here it's everything we need, reachable distance. So I think it's quite perfect. And the archipelago is really relaxing for the weekend time also.
Yeah, I absolutely love the islands. Yeah, and you? What is your opinion about it?
Yeah, Turku is a very interesting place. Like Kimmo said, the traffic is quite good. It's easily accessible. You can take a walk, you can ride, or you can take a bus, which is very convenient as well, very timely. So, and also the work-life balance in Turku is quite good. You can work from the library, or you can come to the lab and work from the lab, or you can go to the main campus buildings and work from there. So it's quite accessible. And
here, what about you, Carlos?
Well, yeah, the city is quite interesting, I guess. Lots of nature, definitely. And you get to enjoy, I would say, most of the seasons. If you like winter, if you like summer, if you like rain, whatever you want, it's here. Everything is reachable, as you say. I come from Mexico, so definitely the trajectories here I were way shorter.
Yeah.
And there's a lot of technology investment here in the city. Lots of projects, trains, buses, taxis, whatever you want, it's here. So, yeah, it's definitely a very good city, and it offers a really great opportunity for students to experience other stuff here.
So now Lukas is going to explain some interesting stuff he has been working with.
So I've just set up Carlos here with, here we have an EMG sensor, so it records electrical muscle signals basically. And then on this other side we have an IMU which records acceleration and rotation. I've set up Carlos with 4 electrodes, so 2 on the middle of his forearm and 2 on his wrist region. These 4 electrodes will measure the muscle activity on the forearm, and they're connected directly to this EMG sensor here. The idea of this thing is to basically measure the hand movement. So during a recording process, Carlos will do some predefined hand motions, for example, stretching out his index. So you can show exactly like this. And then these two sensors here will measure the muscle activity that happened and occurred during this extension, as well as the rotation acceleration of the forearm during this process. And then this data is basically used by classifiers to try to identify which muscle are activated during this motion and how is the arm accelerating and rotating during this motion. And then basically these classifiers will be able to identify what Carlos did only based on how this muscle were activated and how his arm was rotated and accelerated. And at the moment, what I've been working on is dividing this motion into sub-motions. So for example, here by stretching his index, he kept these 3 fingers inside, as well as his thumb, and only his index was extended while his arm moved a bit forwards. So basically all these sub-motions can be divided, which then allow the classifiers to be able to say, okay, this index is extended. So basically, when he would do another motion based, for example, extending this little finger, although this is not a motion from which we would learn, the classifiers are still able to identify this because they've been able to identify which signal occurs when which finger is extended, for instance. So this is what we're working on at the moment with this setup.
Yeah, this is very cool. I believe it has a lot of like applications on, let's say, human-computer interaction, and like, let's say, this like kind of remote control and this smart, I don't know, gloves that you see like in some sci-fi. That's very cool. That's very cool. Thanks a lot. So now we can maybe move on to this robot arm detection, which is Amos is going to explain to us. So can you show us a bit like what is this and how it works?
It's just detecting this yellow ball using OpenCV and a camera that is connected. So from the image frame, it's able to detect this color based on the image pixels that you've defined. And based on the PID controller, it's able to keep this detected object in the center of its image frame. And yeah, that's what it's doing.
Yeah, that's very cool. Like because also like in your life as a researcher, you're also going to teach like master students, bachelor students, and this is part of the educational equipment here in the lab. Can I try playing with this a bit? Oh, this is so cool. Like you see, so I'm literally moving, and so you see the camera detects the object, and then the actual controller kicks in to position the joint of the robot like in the right position. That's very interesting. Now there's a last demo that Kimmo prepared for us, which is in the control of a pendulum, which is also part of the educational equipment. So let's try to see.
Yeah, this is a inverted pendulum. It tries to balance this pendulum in an upside position.
Mm-hmm.
And it has one actuator, a motor that rotates it, and then it has encoder that in the motor shaft, which measures this position, and then it has a one encoder for the pendulum position.
So getting inspired by what? Getting inspired by science? What about you guys?
Smart systems.
Automation.
Imagination.
Technology.
Very cool, fantastic. So thank you for this lovely visit, and see you in the next video. Bye.